So 1.6, represent functions as rules and tables. So we're going to have kind of a definition, and within that we're going to have a couple little definitions as well. So a function consists of and just so you know, sometimes when I write function, I'm going to write FNCT like that. So if you see me do that, that's just shorthand for function. Consists of a set called the domain, which contains numbers called inputs trying to get it so it's not so blurry up there for y'all. And then the other one is a set called the range. It contains numbers called outputs. Now, for it to be a function, a pairing of inputs, I'm going to rewrite it this way. Each input can only have one output. Okay, but the reverse is not true. There can be multiple outputs, but there can't be, it'll make more sense when you see an example of it. But the output can have multiple arrows drawn to it, but the input can only have one. So we have what we call a mapping diagram, which it's basically just another way to represent the functions. So just kind of an example of what that would look like. You're going to have an input column, and we're going to just do the numbers 1, 2, 3, and 4 to make it easy. They're either going to be boxed or circled or something like that. And then we're going to have an output column. And in here we have 0, 1, and 2. They will also be circled. So then, in this particular case, they would have been given to you. And so 1 goes with 0. 2 goes with 1. 3 goes with 2. And then 4 also goes with 2. Okay, so as far as the thing that was written before that in green, each input can only have one output. So each input only has one arrow coming off of it. Okay, but the outputs can have multiple. So the number 2 in the output column has 2 things going to it. That's okay. So if we had this would be a function. And then just for kind of some reference for you, when you think input, okay, you're going to think domain, you're going to think x value, and you're going to think independent variable, okay? So if you hear like x value, okay, we're looking at, that's another name for the domain. It's another name for input. Another name would be the independent variable. Okay, so if it asks for any of those things, we're thinking x values. Okay. If we have y value instead, we would be thinking range. We would be thinking output. And we would be thinking dependent variable. So what this stuff is telling you is that if you were given a function, let's say like y equals x minus 3, okay, if you plug in, now I'm just using it as an example, if you plug in the number 1 for x, okay, whatever 1, it would be x minus 3, so 1 minus 3 would be negative 2, so it would be 1 that goes with negative 2 would be the pairing, okay, but you'll see that more as we do examples. Okay. Let's start to look at some examples. We may do a couple other things with it as well. But the first ones just say to identify the domain and range of the function. Okay, so number 4, our input values are 3, 5, 7, and 8. Our output values are 7, 5, 3, and 2. And they tell us that 3 goes with 7, 5 goes with 5, 7 goes with 3, and 8 goes with 2. Okay, and sometimes they will write these in a table instead, and so rather than drawing the arrows from what they go with, they will just draw it like, so like with this problem, if it was written as a table, it would say input, output, basically then they would put the numbers in here, 3, 5, 7, 8, and then 7, 5, 3, 2. So this just says that whatever's next to each other is what matches up together rather than it having the arrows drawn. So I just want to show you that one so that you see, like, because some of the examples are like this and some of them are like this. Okay. So the domain values are the input values. Okay, so when it asks us for domain, you're just going to list them off with commas between them. So you're just going to go 3, 5, 7, 8. Okay, and those again are your x values. Okay, the range, we're just going to go down 7, 5, 3, 2. So those are your output values. So then just for kind of an example here, this one doesn't ask for it, but would this be a function? Does each input have only one output? Okay, yes. So this one, if it asks for it, it doesn't, but this would be a function. Okay. All right, so then the next ones, they're going to give you the tables like this, and they want to know if it's a function. So, well, at least the ones that we're going to do, they also give you one like this one. But, number 6. So, they have input, output, and it's a table. And the numbers are going down 0, 1, 2, 3, and then 7.5, 9.5, 11.5, and 13.5. So they want to know, is this a function? So does each input have exactly one output? Are there any numbers in the input that are repeated? No, because they're all different here. So this would be a function. Something in my throat, apparently. All right. Let's look at another one. Number 8. It also gives us a table. So in here, going down again, we have 7, 11, 21, and 35. And then we have 13, 8, 13, and 20. So would this one be a function? Okay, so even though in the output column 13 is used twice, okay, there were no inputs that were repeated, so this one would still be a function. Okay, if they were switched, let's say if the inputs were on the right side and the outputs were on the left side, because 13 would be repeated, it would not be a function. Okay, so if the inputs are repeated, then it's not a function. Let's see. All right, so the next ones say to make a table for the function, identify the range of the function. So these ones give you, like with number 14, y equals x minus 3. Okay, oh, look at that. That's the one I said earlier. And then they tell you that the domain are the numbers 12, 15, 22, and 30. Okay, so they want you now to make the table that goes with it. Okay, now my domain values are what values out of the table? Okay, but sorry, let me rephrase. Which column in the table are they going in? Input or output? Input. Okay, so I'm going to draw my table over here to the side. I'm going to do input and output. All right, so we were given the input values, so I'm going to write them down in the left column. So 12, 15, 22, and 30. Okay, now I said domain is it X or Y values? Domain is X, so we are going to plug in each of these values individually. So we're going to end up doing 4 problems within this, okay, to find the output value that goes with the input. So we're going to start with 12. So we have y equals, we're going to replace the x with 12. 12 minus 3. So what is the first one? 9. So then we go over to the output column next to 12 and we write 9. Okay, and then we're going to do the same thing with 15. So I'm going to give y equals, I'm replacing x with 15. So 15 minus 3 is what?
Attention, will all 6th graders please come to the Bruin for pictures? 6th graders, please come to the Bruin.
Okay, yes, it's 12. So then in the output column next to 15, we put 12. Then let's do 22. So y equals 22 minus 3, which is what? 19. So we put that in the output column for 22. And then lastly, we do 30. Y equals 30 minus 3, which is what? 27. So the output column that goes with 30 is 27. So that's all that this problem is asking you to do. Okay, so it's got several steps to it, but we're ultimately just trying to find this here. Let's look at one more of those. Number 16. We've got y equals 3x plus 4, okay, and they tell us that the domain values are 0, 5, 7, and 10. So we're going to be doing the same thing we did in the last one, but the difference with this one is that we have to multiply the x values by 3 first, then add the 4, okay, to follow PEMDAS rules. So I'm going to go ahead and make my table over here. Input, output, they're almost all the same size. So then in the input column, I'm just going to go in order 0, 5, 7, 10. And then just like in the last one, I'm going to plug in each of the values and solve them. So I'm going to start with 0. So y equals 3 times 0 plus 4. So what is that going to give us?
4.
4. And then we put 4 in the output column. Then we're going to do 5. Y equals 3 times 5 plus 4. So what would that one be? 19. Put that in the output column. 7. So we get y equals 3 times 7 plus 4. 25. Fill that in. And the last one is going to be for 10. 3 times 10 plus 4. 34. Not too bad, right? Just kind of combining everything we've been doing. So the other thing we can do is we can do the reverse of this. So this will be our last problem that we do. Is they can give us this table, okay? And then we can find this equation, okay? So they don't give us anything too crazy, thankfully. But for number 20, they give it to us, and I'm just, because of the way they write it, I'm going to do it this way just so we see it differently. They write it actually going sideways instead. So they say input X, output Y. And then they give us 0, 1, 2, and 3 for our input values. And then our output values are 2.2, 3.2, 4.2, and 5.2. So, when you look at this, okay, the first thing that you're always going to have is whatever, when x equals 0, okay, you're always going to write this number down, okay? So you're going to start out with y equals 2.2, and then we're going to find out what we have to do from there, okay? So it's always this first value when x is 0. So if we had, well, I'll show you in a second. How do we get from here to here? What happens? How do we get from 2.2 to 3.2? Adding what? What number do you add to 2.2 to get 3.2? 1. So this is going to be plus 1 to get from 3.2 to 4.2. 1. Okay, and then it's going to be the same thing for the last one. Okay? So, what this tells us is that for every x that gets added, okay, it's adding 1 to it. So all we have to do then is say plus x. Okay. I was looking at. Anyways. That's all you have to do for that. I'm not going to assign you one like it because the one they give you is super weird. So, anyways, as long as you can do that one, you're good. All right, so then for your homework assignment, now today's Wednesday, so it's not due till Friday, but I would like you to do 3, 5, 7, I'd like you to look at 9 and 10. They're finding the error in what the person did. So just see if you can find the error there. And then 15 will be the last one out of that section.